2017 free response, number 6, AB Calculus. This is going to be also calculator inactive. Let f be the function defined here, a lot of trig in there. Let g be a differentiable function. That word is important. Hold on to that. By the way, I'm going to go ahead and tell you why it's important. If a function is differentiable, I just feel like writing on my paper, it is also continuous. If I can take the derivative of it, then I can draw it without lifting my pencil, right? Or pen, whatever. The table above consists of values of g and its derivative g prime at selected values of x, okay? So far we've been introduced to a function as an equation, a function that's differentiable and therefore continuous as a table, and h is a function whose graph consisting of 5 line segments is shown in the figure above. So we have all these little pieces. I just want to point out something that may or may not happen later. Not differentiable here, 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 or here. Just say it, okay? Because the slope from the left and the right would not match up. Part A, find the slope of the line tangent to the graph of f at x equals pi. Okay, we're dealing with f. That would be this guy right here. They are not asking for the equation of the tangent line. They're asking for the slope of the tangent line. So here we go. Number 6, part A. I'm going to write down f of x equals cosine. Oh, my handwriting got sloppy. 2x plus e to the sine x. And if I want the slope of a line tangent to a graph, then I'll just need the slope. So let's find the derivative. So f prime of x equals, all right, derivative of cosine would be negative sine 2x. Derivative of 2x would be 2. And then derivative of e to the x is e to the x. But I feel a little bit of trig coming on in this one too because of the chain rule. So cosine x happens there. All right. Glance at that, make sure it's right. If it's wrong, I might cry. And it is absolutely correct. Okay, glancing through there. So I want to know the slope at x equals pi. So we're going to plug in a pi. This tests our knowledge of the unit circle. Negative 2 sine of 2 pi plus cosine of pi e to the sine pi. All right, negative 2. All right, sine of 2 pi is 0. Yeah. So negative 2 times 0, that goes away. And then cosine of pi is negative 1. E to the sine of pi is 0, so e to the 0. And so that's going to give me 0 minus 1, so negative 1. Some of that can happen in your head. That answers part A. Part B. Here we go. Let k be the function defined by k of x equals h of f. I see a composite function. Find k prime of pi. Okay, good to know. So k of x is equal to h of f of x. And they're asking for the derivative of k at a specific x value. Let's go ahead and find the derivative of k first. H prime of f of x times, I don't know why that dot's there, just for fun, I guess, f prime of x. And I want to know what happens when I plug in a pi, so let's do it. So k prime of pi equals h prime of f of pi times f prime of pi. Okay, well, lucky us, we know what f prime of pi is, right? So we already know that this is negative 1. We found it in part A. The way people generally grade, if you would have missed part A, but would have used that answer in part B and proceeded correctly with your wrong answer, you'd get some credit. All right, so h prime of, we need to find out what this is. We don't know what that is yet. We do know that this is negative 1. So we're kind of hitting a snag here, changing colors. Don't do that on the exam. You'll be writing with a pen. Sol, not pen. Pen, sol. F of pi, just doing my work over here. We're going to plug in a pi and get cosine of 2 pi plus e to the sine pi. All right, cosine of 2 pi, cosine 2 pi would be positive 1, so we have a positive 1 plus e to the 0. E to the 0 is 1, so we're going to have a 2 there. So that's going to give me this. We need h prime of 2. All right, let's keep going. I need h prime of 2. Well, I'm going to retrieve that from my graph, and my graph is here, of course. And I need the slope at 2, and the slope at 2 is basically the slope of this line. That would be negative 1/3. Do your rise over run, negative 1/3. So I'm going to have negative 1/3 times negative 1. Do this in your head. You're going to get 1/3. There we go. I'm gonna pause right here. Instead of doing it at the end, I'm gonna go ahead and I'm gonna go ahead and grade my paper so far. I get 2 points for f prime of pi. I've already earned my 2 points there. So far, so good. And I get a point for k prime of x, which we found to be this. So you needed to find that first. And it is correct. It's staring us in the face. It's the chain rule. And then I get a point for k prime of pi, which is positive 1/3. So far we've earned both sets of points, so 4 so far. And we can look ahead and see the answers. Here we go, part C. Life's not like that though, is it? Let m be this function. I think it's worth writing because we might need it later. G of negative 2x times h of x. And we're asked to find the derivative at a specific value. So before we find the derivative at 2, let's find the derivative. And glancing at the answer key, I do realize that that is one of the things they're looking for. And you have to find it anyway. So don't be like, oh, are they looking for this or not? In this case, you have to find it. You need to know it. So let's just go ahead and find the derivative. So this is going to be product with a chain, actually. So f prime g plus f g prime. I'm using f and g arbitrarily here. So the derivative of this, multiply by the derivative of negative 2x, so negative 2, and then h of x, plus, and then keep this one intact, and then h prime of x. There we go. So there's our derivative. We're going to plug in a 2, so m prime of 2 equals negative 2 g prime of negative 2 times 2, h of 2 plus g of negative 2 times 2. Go ahead and put a negative 4 if you like. H prime of 2. Negative 2, g prime of negative 4, h of 2. Could have saved myself a step and went ahead and did all this because some of it's obvious. There we go. Now I'm going to just start retrieving values from the graph, from the table. So negative 2, g prime of negative 4. There it goes. G prime of negative 4, that would be negative 1. H of 2. H of 2, and this is the graph of h, not h prime, good to know. So h of 2 is there. Where is there? Okay, think about it logically. You already know the slope of this is negative 1/3. So if I'm going to go to here, I'd go over 3 and down 1. Here I'd go over 2 and down, well, not fully 1. I'd go 2/3. That's 1/3, 2/3, 3/3. Negative 1/3, negative 2/3, negative 3/3. So it's negative 2/3. Negative 2/3. Okay. You can get all technical with it and use equations of lines. I don't feel like it. Plus g of negative 4. Again, that's going to come from here. And h prime of 2, which we know to be negative 1/3. That's the slope. And then we will proceed with this. Now, in more recent exams, you could stop here. I'm going to keep going because I just hate to leave things like this. But in order to avoid errors that would cause you to miss points, you can really stop here at the way they grade it as of the recording that I'm making right now. So negative, negative, negative is going to give me, well, negative. And so I'm going to have negative 4/3. Minus 5/3. That's going to give me negative 9/3, which is negative 3. Skip as many steps as you find necessary. Okay, one more part, and this one's going to get a little tricky. And the way it's worded from the very beginning lets me know that they're asking about the existence of something. Let's see. Is there a number c? Does something exist in the closed interval from negative 5 to negative 3 such that g prime of c? All right, pause. They're asking for the existence of a number between negative 5 and negative 3. They want to know, is there some x value, we're going to call it c, but is there some x value between here and here, and it's going to involve g. So we're looking here, and it actually involves g prime equals negative 4. So they're asking for the existence of a specific slope. Justify your answer. Okay, there are 3 existence theorems. Number 3 is the extreme value theorem. It says that we have a highest, we have a lowest if we've met some certain conditions, basically continuity. And that they're not asking high or low. So this is not extreme value, not high or low. Then that's the third one. The first one that we learned was the mean value theorem, and that says is there a value that exists that is equal to something? And it looks like that, but it's not, because they're really saying, do we have a slope equal to that? So that is the second one. That's the mean value theorem. In order for the mean value theorem to apply, then we need to have two things. We need to have, and this is beautiful, continuity, check. We also need to have a slope on this interval that matches that. And we do. I'm going to show it to you in a second. So here goes. I'm going to just kind of start my work and just go with it from there. So here goes part D. They are asking if there is a slope somewhere in between -5 and 3, x values, such that that slope would equal -4. And we can do this by finding the slope between these 2 points. This one right here and this one right here. Now, we might be tempted to go over here and find the slope using the -3 and the 4 here. No, 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 no. We're going to find the slope using the coordinates, and it will match the derivative if the mean value theorem applies. Okay? All right, so here's what's going to happen. We're going to find g of -5 minus g of -3 over -5 minus -3. There we go. So that's going to give me -2 in the denominator, and that's going to give me, I'm looking at the table here, 10 minus 2. So you do all your math, you're going to get -4. So here's the deal. We just found, and I'm going to write stuff that you don't have to write on the exam, but this is the average rate of change. Average rate of change of g on the interval from -5 to -3. That's good to know. And we also know that g is continuous, right? Let's start framing our answer. This is the slope they're looking for. I think we're good to go. Because g is differentiable and therefore continuous, and because henceforth yeah, and because, sorry, got like weird, just gonna put on like one of those big long wigs. Because the average rate of change of g on the interval from -5, whoa, that's an ugly way of writing it, isn't it? Ugly brace there. Is -4. The mean value theorem applies. It's good to put that in there. If you don't say MVT or mean value theorem, will you get credit? I'd be reluctant. So we are using the mean value theorem, so talk about it and say it. Say MVT. You can abbreviate it, of course, but you need to say it. The mean value theorem applies, and there exists, I'm just going to talk about what does exist. There exists a C how can I word this part? Try not to word it like the answer key is. There exists a C. Not such. I gave in. -5 to -3, such that g of c, we don't know what it is, but we know it's between -5 and -3, is equal to -4. All right, let's grade this mug. I'll start with part D since we just did it. We needed this to get a point, and we needed the justification using the mean value theorem. And again, continuity and the average rate of change. We had to have those. And then we had the explanation down here. So it was worded well. And for part C, we needed the derivative of x. That was worth 2 points, which we found, and it was right. And we needed the slope at 2, slope of m at 2, which was worth 1 point. It was -3, and that was also correct.